of what we have covered, right? I will say, if you pay attention closely, probably 100% of the things that we'll be talking is going to be in the exam, but I will not tell you which part, okay? You have to study, but basically, more or less, you will know, right? So, we covered the different areas of how cognition can be kind of like studied, and we have also done the history of AI. Okay, so we went on to the second topic, which is on perception. And during this topic, we covered quite a number of things relating to how we perceive, how we understand an object that we see. Okay, seeing an object and making sense of the object is two different things. Okay, so one is pattern recognition, another one is perception. Okay, so when we talk about perception, it's basically getting lights into our eyes and then gets that process in our brain for us to actually make sense of the different signals that comes through our sensory organs so that we can actually have some kind of experience. Okay, so that is the definition of perception. Then we went to talking about Gestalt. So this was part of your eye tracking project as well. Okay, so we use this data, Gestalt principle or law of
Bro, just record the whole thing.
perceptual optical illusion. So we covered different types of Gestalt principles. So these are just a few examples. Okay, you can get the more complete example of Gestalt principle in the notes itself. Okay, so you need to know what these Gestalt principles are. Okay, how they are different. Then we went on talking about different theories of pattern recognition. So earlier I mentioned about pattern recognition, I mentioned about perception, right? Two different things. Pattern recognition is about understanding what we see. Okay, perception is about being able to see or to receive the senses from our sensory organs. Okay, so we have covered at least four different types of theories. One is template theory, feature integration, and structure theory. So in short, okay, template theory refers to a theory that is basically there as is. Okay, so if we need to recognize an object, we need to have a template for that object. Okay, if let's say the object is tilted or happen to be in different orientation, different size, different font size for text as this, then we would be able to identify this template theory. So all of these theories comes with its own advantage and disadvantage. Make sure you know. And when we talk about these theories, when we have this template theory, it's got its limitations, certain limitation that brings us to the feature theory. Okay, so this feature theory actually allows us to recognize different parts of the object. If you look at here, you are able to identify all these different objects, even though some of them are an integration of different items or different objects. How are we able to do that is basically described from this theory. Then we went to feature integration theory, which is an extension of this feature theory. What the extension is, please go and look at the notes. Feature integration theory actually allows us to be able to recognize an object based on a more separated kind of like phases of um, the process when we identify the object. So first we have what is called this pre-attentive stage, and then after breaking down the object into all these different features, then we tend to combine them at this level where we put our attention. Okay, and this is where we have this thing called attenuator. Right? So if you know, like if you've heard of like music, you can turn like your volume up and down. It's actually that concept, right? And then eventually it allows us to be able to recognize the object, okay? But again, this feature integration theory has its own limitation as well. Go and find out what the limitation is. That allows us, brings us to the structural theory. So in this structural theory, it's meant to be a better approach because we are able to separate the objects, to be able to identify an object, we actually integrate these different theories or different combination of features in the upgraded form called Geon, because this is basically the 3D format um, of the features that was introduced in the previous former theory, which is feature integration theory. Okay, so all of this actually comes in place. So it's like it's basically related. It's got its own kind of like limitation that introduces the next model. Okay, then we went on talking about AI perception, what it is. Okay, so we understood about how human perceive things, what is perception, what is pattern recognition, and then eventually we also talk about how AI systems can model these perceptions that we humans have in terms of our vision, in terms of hearing, in terms of basically tactile. So some of the things that we cover is basically the application of the AI theories in predictive models. So we are able to detect an object, identify an object, do segmentation, recognize pattern, be able to understand text, language, all of this because of pattern recognition. Okay, so of course it doesn't just come from the camera perspective, but it's also from textual perspective, audio perspective, and different others. Okay, so at the end of the lecture, we also look at this aspect where we wanted to do a relationship. Okay, so we understand from very beginning of the lecture, we look at how we perceive object, right? So when our eyes sees a signal, right, it goes through all of these different a series of processes. Okay, so this aspect, this part, it goes to V1, V2. To some extent, some of this is actually being represented in deep learning models or in CNN models. Okay, so this is basically what we understand about CNN is very much a replication of how the human brain actually works. Okay, so go and try to see the association. Okay, so then we will move on to topic 3. Which is on cognitive architecture. So there was no specific lecture notes on this because it was very much your own kind of like what is that study, but basically the entire work is basically related, or the entire chapter is very much related to ACTAR. Okay, so ACTAR is a type of architecture that allows us to understand or allows us to create a computer system or computer algorithm that can describe or explain about problem solving. Okay, so it actually represents a lot about how we, in a way, human develop intellectual skills because it's able to tell you what is the series of tasks or the series of rules that gets executed. Okay, in that term. So you were supposed to do some kind of kind of like testing or training ACTAR. So I do not know whether or not you did. By the way, go back and have a look. So there's like two parts in ACTAR that is covered. One is the declarative part, which is basically keeping the information part, and the procedural part is about using, basically having an algorithm that works on the information, which is the declarative part. So there's actually two representation over here, and the information is actually being represented in the form of chunk or units of knowledge, where the procedural very much works in the form of rule-based systems. Okay, so both of these actually works, and it actually represents different things lah. So as you can see, events, facts, ideas, these are the factual part. Motor skills, mental representation is basically the procedural part. Okay, so all of these we have already covered, and we have also looked into how the different nodes are actually being activated during memory retrieval, which actually helps us to understand how this process actually works in our minds or in our brains. Okay, so this is one of the reasons why ACTA is very much one of the earliest model that mimics the representation of how human problem solve. Okay. So yes, so these are some of the things that's covered that we can look again. Okay, so we went on to the fourth topic, which is on attention. Okay, so some of the learning outcomes or the things you're expected to know from this topic is very much related to the foundations of how we understand things, and mainly on visual attention or eye tracking. So by now, hopefully, I think I do not have problems with you understanding eye tracking because you probably have understood that quite well. So we have covered, before we went to the eye tracking part, we look at several cognitive models. We start off with the bottleneck theories, and then we try to make an understanding why is it that we have to be selective with the information, with the amount of information we receive. Mainly because we're not able to process so much information because we get billions of them in just a matter of seconds, right? And then we look at the difference between attention and consciousness. What is what and what is which, whether or not one is independent or dependent with one another. Okay, so do they have a close relationship? To what extent? Okay, so all of these we have covered. And we went on talking about the different types of attention. So as you mentioned just now, there's two types at least. One is selective, one is divided. And if you look here, they are even broken down into different aspects. Okay. So mainly, roughly speaking, for selective attention, we only process one information at a time. But for divided, it's kind of like processing all the inputs, not to say at once, but it becomes faster. Okay, so that's the idea. So you can get all the details of this in the lecture notes, and there were like experiments that supports the different aspects of both selective and divided attention. Okay. So we also look at the models of selective attention. There were at least three that we covered. One is early selection, intermediate, and late selection. Okay, so they differ in terms of when we actually allow attention to be, when we focus our attention so that we can process some kind of meaning. Okay, so in a nutshell, this is what differs all these different models. Okay, so the first one is the broadband model, and we know that we can hear our name being called in a noisy environment. But there's also limitations to that. So that's why these models, again, just like the perception model, this one also have its own limitation and advantages, and make sure you know them all. Okay. So there's certain aspects of when each of these model stops, kind of like paying attention. Okay. So at this model, which is the second model called the Trisman model, is basically allows us to filter attention, because we are still able to identify certain information, such as the Dear Unchained experiment, if you remember. This is one of the things that we are able to do. Okay, but eventually we have this Dutch Norman, or Dutch Norman, of selective attention, where there are words that can be ambiguous. Okay, they are playing at the bank. Okay, so is it referring to the river bank, or is it playing to the financial institute? Okay, so these are the things that's been covered, at least in these three different models that we talk about. Then we went on talking about the different levels of cognitive load. So there is this thing called high load and low load. Okay, so what low load is when you do something and you can still do something else. Okay, this is when you have reach certain level of expertise. But for someone who is developing a new skill, for example, playing piano, okay, you're probably not able to focus and do other things at once. Okay, so this is what differs the different kinds of cognitive loads that we covered in our lecture. Okay. So we talk about divided attention. So we know that our ability to be able to do many things at once is at least being reflected by two things. One is by practice, and the other one is task difficulty. And we have covered these things. So this is one of the example of Stroop effect, where saying out the color, don't read the word. Okay, so one is probably easier and faster than the other. Okay, so you know which one that is. But this is actually one of the aspects that influence our divided attention. And the next one is on task difficulty. So we know that there was an experiment that supports this divided attention, that the more we train ourselves to do difficult tasks, the easier it is for us to respond to identifying the task, okay, because of practice. Okay, so task difficulty also makes an impact on how well we can divide our attention. Okay, then we went on talking about visual attention, which is basically the introduction of eye tracking in general. So we covered overt and covert attention, what they are. You can refer them in the notes. And this is basically an example of the covert and overt attention, or phobia or extrafoveal area, because we are able to just focus on one area, but still, to some extent, we're still able to focus the area around it. Okay, so not all the time, but this basically gives an kind of like introduction of why measuring the eye gaze behavior can tell us a lot about our state of attention. So when we talk about eye tracking, okay, the general idea of doing this is basically to look at where people are looking, where people are looking, what people are looking, how long they are looking, and what is the duration of the order of their visual kind of like eye movement. What we are not able to tell from here is why they are looking. Okay, so make sure you understand the things that can and cannot be done using an eye tracking kind of assessment. Okay, so eye tracking can tell you all these things listed, but why you're looking, that one requires additional data sets such as EEG or survey questionnaire or any other assessment. So we went through several kind of like case studies. This is just an example. Okay, so you yourself went through case studies. So when we had the talk by our industry SDS associates, some of you also went through the examples. So these examples that you went through would probably, hopefully, help you with your exams as well. So make sure that you know the different types of eye movements, fixation, saccades, move, pursuit, vengeance. These are all just some examples. Okay. There's some differences to this matrix. Some of these matrix you have used in your analysis. So make sure you know what they are and why they are different. Okay. So we have also looked at different visualization formats. So you have covered this in your projects. So just get a better understanding of what each type of visualization can tell us. Okay. So that wraps up our topic 4, and now we move on to topic